Hello grade 9 students. Today we will continue our unit electrochemistry, but now part 3 oxidation number. At the end of this video you will be able to define or determine the oxidation number of a given element. As usual, it's better to start recalling some information. As you can see here, magnesium atom make transfer of 2 electrons to copper ions to become magnesium ion. So magnesium atom, by losing these 2 electrons to become magnesium ion, it undergoes oxidation half reaction where it's oxidized. These 2 electrons that are given to copper ions to become copper atom. In this case, copper ion undergoes reduction half reaction in which it gains electrons and it's reduced. So, the species that undergoes oxidation half reaction, it's called reducing agent, while the species that undergoes reduction half reaction, it's called oxidizing agent. Consider this reaction. Carbon plus oxygen gives carbon dioxide. As you see here, carbon atom reacts with oxygen element in order to give carbon dioxide. As you see here, can you see the gain or the loss or the transfer of electrons between these two reactants? Unfortunately, no. So, the transfer of electrons is not clear in the above chemical reaction. So how can we determine if this reaction is a redox one or not? Using the oxidation number of elements. So we can know if a reaction is a redox or not, even though the transfer of electron is not clear, using oxidation number. As you know, most of the atoms are not stable except atoms of column 18. So atom, in order to be stable, it tends either to share electrons with other atoms or transfer electrons to other atom, either loses electron or gains electron in order to form compounds. How are ionic compounds formed? Consider the following ionic compound, NaCl. So this is the Na. Na is in column 1, so it's metal. The elements of column 1 tends to lose 1 electron in order to be stable and become Na+. Here, chlorine in column 17. So chlorine is in column 17, it's non-metal. It tends to gain 1 electron to be stable and become Cl-. So Na plus and Cl- attract each other by electrostatic force to form an ionic compound. So Na loses 1 electron and Cl gains this 1 electron to make a chemical combination. These numbers are called oxidation state. So, what is the definition of oxidation number? Oxidation number or oxidation state is a number that is assigned to an element in a chemical combination. This number represents the number of electrons that an atom can gain, lose, or share when chemical bonding with an atom of another element. The oxidation number that is assigned to an atom can be either positive, negative, or 0. The oxidation number is usually written in Roman numbers from 1 till 8. This is for study. Now, what are the rules to assign the oxidation number? Rule number 1. The oxidation number of an element is equal to 0. Remember always, the oxidation number of an element is written per atom. Example now, Na, oxidation number of Na because it's an element is equal to 0. Cl2, because Cl2 is an element, the oxidation number of Cl is equal to 0. As we said here, the very important note that we write the oxidation number of an element per atom. Yani we don't say oxidation number of Cl2, we say oxidation number of Cl is equal to 0. Oxidation number of Fe equal to 0 because it's an element. Oxidation number of O3 because it's an element, so the oxidation number of O is equal to 0. And the oxidation number of H2 because it's an element, the oxidation number of H equal to 0. Rule number 2. The oxidation number of a monoatomic ions is equal to the charge of the ion. Example, the oxidation number of H plus is equal to the charge of this ion, yani it's equal to plus 1. The oxidation number of Al3 plus, because it's a monoatomic ion, so the oxidation number of it is equal to the charge of this ion, so the oxidation number of Al is equal to plus 3. The oxidation number of O2 minus, because it's a monoatomic ion, the oxidation number is equal to the charge of this ion. The charge is equal to minus, so the oxidation number of O is equal minus 2. The oxidation number of Na3 minus, because it's monoatomic ion, so it's equal to the charge of this ion. The charge is 3 minus, so the oxidation number of N is equal to minus 3. The oxidation number of Cl minus, because the charge is minus, so the oxidation number of Cl is equal to minus 1. Rule number 3. Oxidation number of an element in a compound. For hydrogen, the oxidation number of hydrogen in a compound is equal to plus 1. So always hydrogen found in any compound, its oxidation number is equal to plus 1. But if hydrogen is an element, sure, the oxidation number is equal to 0. Example, the oxidation number of hydrogen in H2O always equal plus 1. Oxidation number of hydrogen in H2SO4 compound also equal to plus 1. The oxidation number of hydrogen in an NaOH compound also it's equal to plus 1. So when we find oxygen element in a compound, its oxidation number is equal to minus 2. But if oxygen is an element, sure, the oxidation number is equal to 0, as we said in rule number 1. Exception, in hydrogen peroxide compound H2O2, the oxidation number of oxygen is equal to minus 1. This is the only exception. Only oxygen in H2O2, its oxidation number is equal to minus 1, while in any other compound, its oxidation number is equal to minus 2. Example, the oxidation number of oxygen in H2O compound is equal to minus 2. The oxidation number of oxygen in H2SO4 compound also it's equal to minus 2. The oxidation number of oxygen in NaOH compound also is equal to minus 2. But the oxidation number of oxygen in H2O2, this is the exception, it's equal to minus 1. Let's continue with rule number 3. The elements of group 1, example Li, Na, and K, their oxidation number in a compound is equal to plus 1. Example, Na2O, the oxidation number of Na, because it's in group 1, so its oxidation number is equal to plus 1. The oxidation number of K in KCl compound, because it's in group 1, its oxidation number is equal to plus 1. Now, elements of group 2, example Ca, Mg, and Be, the oxidation number of these elements in a compound is equal to plus 2. Example, the oxidation number of Ca in CaO, because it's in group 2, its oxidation number is equal to plus 2. The oxidation number of Mg in MgCl2 compound because it's in a group 2, so its oxidation number is equal to +2. Continue also with rule number 3. For aluminum in a compound has an oxidation number equal to +3. Example, the oxidation number of aluminum in Al2O3 compound equal to +3. Oxidation number of Al in AlCl3 compound also it's equal to +3. Rule number 4 now. The summation of oxidation number of elements in a compound is equal to 0. Means the summation of oxidation number of each element times the number of atoms of this element equal to 0. Remark, the word summation is symbolized by this symbol. Example, the summation of all the oxidation number of these elements inside this compound is equal to 0. So here we say that how can we expand this formula? We say that the oxidation number of H times the number of each H atoms plus the oxidation number of sulfur times the number of sulfur atoms plus the oxidation number of oxygen times the number of oxygen atoms. Remember that we take the oxidation number of one atom only, per atom only. So here we say the oxidation number of H, of S, of O. Okay, or the oxidation number of H times how many H we have in this compound, 2, so times 2, plus oxidation number of S, how many sulfur atoms, only 1, so times 1, plus the oxidation number of O times how many oxygen atoms in this compound, 4. The summation of the oxidation number of each element is equal to 0. So here you studied that the oxidation number of hydrogen element in a compound always is equal to +1, so +1 times 2. Here the oxidation number of sulfur, we don't know it, and we know also the oxidation number of any oxygen atom inside any compound always it's equal to -2, so -2 times 4 now. So here we have +2 plus oxidation number plus -8 equal to 0. Now oxidation number equal 8 minus 2 equal +6. So the oxidation number of sulfur equal +6 in Roman. Please don't forget to write the final answer in Roman. You can calculate all the calculation in a real number, but at the end you should write the answer in Roman. Rule number 5. The summation of oxidation number of elements in a polyatomic ion is equal to the charge of the ion. So here the summation of the oxidation number of each element times the number of atoms of this element equal not to 0, but it's equal to the charge of this ion. Example, the summation of the oxidation number of all the elements of CO3 2- equal to the charge of this ion. So دايما نشوف what is the charge of the polyatomic ion, so the summation of the oxidation number equal to the charge. So here the oxidation number of carbon times how many carbon atoms plus the oxidation number of oxygen times the number of oxygen atoms all equal to the charge of this ion, that is -2. So, or we can say the oxidation number of carbon times only one carbon plus the oxidation number of oxygen times 3 equal to -2. Here we don't know the oxidation number of carbon, but we know the oxidation number of oxygen in any compound. It's equal to -2. So now we write oxidation number of carbon plus 3 times -2 equal -2. Oxidation number of carbon times -6 equal -2. oxidation number of carbon equal -2 plus 6 equal +4. As we said, all the calculation can be written in a real number, but at the end you should write the answer in Roman. So you should say the oxidation number of carbon is equal +4 in Roman. Application. Find the oxidation number of the highlighted element in the following ions and compounds. A. SO2, B. NH4+, C. NO3-, and D. H3PO4. So now, pause the video, try to solve this application in your chemistry copybook, then correct your answers. Use the set of rules you just learned to assign and calculate oxidation numbers. First, the oxidation number of sulfur in SO2 compound. The oxidation number of oxygen in a compound is equal to -2 as you studied. Also, you studied that the summation of oxidation number of elements in a compound is equal to 0. So, the summation of the oxidation number of each element times the number of atoms of this element equal to 0. Then, you should write the oxidation number of sulfur times the number of sulfur here, only 1, plus the oxidation number of oxygen times the number of oxygen, that is 2, so times 2, all equal to 0 as you studied in this rule. Also, you studied that the oxidation number of oxygen in a compound equal to -2. You can substitute here -2, so you have oxidation number of sulfur plus 2 times -2 equal to 0, oxidation number of sulfur -4 equal to 0, so the oxidation number of sulfur equal +4. Don't forget to write it in Roman, oxidation number of sulfur equal +4. Now part B, the oxidation number of nitrogen in NH4+. You studied the first rule that the oxidation number of hydrogen in a compound is equal to +1, and you studied that the summation of the oxidation number of elements in a polyatomic ion is equal to the charge of the ion. So the summation of the oxidation number of each element times the number of atoms of this element equal to the charge of this ion. Then the oxidation number of nitrogen times 1, because only one nitrogen element, plus the oxidation number of H times 4H equal to the charge of this polyatomic ion, which is +1, so it's equal to +1. Then the oxidation number of nitrogen +4, we substituted the oxidation number of hydrogen in a compound with +1, all are equal to +1. The oxidation number of nitrogen +4 equal to +1. The oxidation number of nitrogen equal +1 minus 4. The oxidation number of nitrogen equal -3 in Roman. Now part C, the oxidation number of nitrogen in NO3-. You studied that the oxidation number of oxygen in a compound is equal to -2, and the summation of the oxidation number of elements in a polyatomic ion is equal to the charge of the ion. Here it's equal the summation to -1. So you can write now that the summation of the oxidation number of each element times the number of atoms of this element equal to the charge of the ion. So the oxidation number of nitrogen times the number of atoms here, 1, plus the oxidation number of oxygen times the number of atoms, which is 3, equal to -1. So substitute now oxidation number of oxygen with -2, oxidation number of nitrogen plus 3 times -2 equal to -1. So the oxidation number of nitrogen is 6 equal to -1. Now the oxidation number of nitrogen equal -1 plus 6. So it's equal to +5 in Roman. The last one, oxidation number of phosphorus in H3PO4. You know that the oxidation number of hydrogen and the oxidation number of oxygen in the compounds is equal to +1 and -2 respectively. So now you say that the summation of oxidation number of elements as you studied, it's equal to 0. Summation of the oxidation number of each element times the number of atoms of this element equal to 0. Now you can substitute the oxidation number of hydrogen times 3, which is the number of hydrogen atoms, plus the oxidation number of phosphorus times 1, because only we have one phosphorus atom plus the oxidation number of oxygen times 4, which is the number of atoms in the compound, all equal to 0. You can now substitute within the oxidation number of hydrogen and oxygen. So 3 times plus 1 plus oxidation number of phosphorus plus 4 times minus 2 equal to 0. Now 3 plus oxidation number of P minus 8 equal to 0. Oxidation number of phosphorus now it's equal to plus 5. Don't forget to write it finally in Roman. To sum up, these are the rules for oxidation state or oxidation number. If the element is alone, its oxidation number is equal to 0, while if it's in a compound or monoatomic ion, the hydrogen is plus 1, the oxidation number of oxygen is equal to minus 2, but only we have exception. The oxidation number of oxygen in H2O2 is equal to minus 1. Elements of group 1 is equal to plus 1, their oxidation number. The oxidation number of elements of group 2 equal to plus 2, and the oxidation number of aluminum is equal to plus 3 in a compound or monoatomic ion. So the summation of oxidation number of elements in a compound is equal to 0, and the summation of oxidation number of elements in a polyatomic ion is equal to the charge of the ion.